Hey guys, in chapter 6, we are going to be taking a look at the periodic trends, and you all are going to be doing a project in order to gain an understanding of the periodic trends, how they were established and how they work. Before you can do that though, I need to spend some time with you going through what the trends actually are so that you can know what it means to measure ionic radius or atomic radius or electronegativity. And so we're going to spend today kind of just overviewing what those trends are before you begin your project, before you start unearthing how those trends come to be and how they're used and what they mean for us in terms of understanding the periodic table, which will all be part of your project. In today's lesson, I'm going to be kind of hitting foundational terms from chapter 6 that will prepare you to understand those periodic trends. So the first thing we need to do is introduce a very common behavior of atoms, which is forming an ion. So we had talked already about isotopes, which are atoms who have gained a neutron or lost a neutron. And now we need to spend some time discussing what an ion is. So an ion is an atom that has gained or lost an electron. It does this in order to become like a noble gas. Noble gases are a group on the periodic table that have the perfect valence shell configuration. So we have a lot of words to unpack here. So let's start with a valence shell. A valence shell represents the outermost electrons in an atom. So I've put up two really commonly used atoms on the board, and each of them has their valence shell. The valence shell is the outermost ring. So right here, this is the valence shell, and also this outermost ring over here. So both of these are the valence shell. In sodium, there is one electron in the valence shell, right here. This is it, one. For chlorine, there are 1, 2, 3, 4, 5, 6, 7 electrons in the valence shell. This valence shell changes the way an atom behaves. If you want a grand total of 8 electrons in your valence shell, which they do, okay, that's called the Octet Rule. If the goal is to end up with 8 electrons in the valence shell, what the Octet Rule tells us, the Octet Rule says most atoms, not all, we don't want to say all, okay? It's too complicated. Most atoms want 8 electrons in their valence shell. But how they're going to get 8 electrons in their valence shell depends on their valence shell. So if we look at sodium, if sodium wants to get 8 electrons in its valence shell, it could either add 7, find, buy, collect 7 electrons, or it could lose 1. Picture that. If I take this 1 electron away, sodium has now 8 electrons in its valence shell, and it is happy. So sodium wants to lose an electron, where chlorine has 7 electrons in its valence shell. It doesn't want to have to try to lose 7 to get 8 electrons. It would rather gain 1 electron to get 8. It would rather gain 1 electron here to get 8 electrons in its valence shell. So once an atom has done this, once it has made its move to either gain or lose an electron, we say that that atom has become an ion. So there are 2 kinds of ions: cations, which have positive charges because they have lost electrons, and anions, which have negative charges because they have gained electrons. It's an important moment right now to remember that electrons are negative. So if you lose an electron, you're losing negative, you're becoming positive. Are you with me? Where if you gain an electron, you're gaining negative, you're becoming negative. Yes? Great. Okay, so we get cations and anions. So if we look back at our example of sodium, sodium lost an electron. So is it a cation or an anion? Well, if it loses an electron, it becomes positive, it becomes a cation. So let's go through those ideas. Sodium has lost an electron. Sodium lost an electron. So sodium now has 11 protons and 10 electrons. Or it has 11 positives and 10 negatives. So all together, sodium is now a +1 charge. And we call this a cation. Sometimes students will call this a cation because in English, tion says shun. Try to avoid that. This is a cation. It's a compound word, cation. And a cation has a positive charge. And there's two ways that I always remember this because you know I'm bad at memorizing and I like tricks to remember everything. So a cation, if you write it like this, so sodium forms a cation. See how I made the plus sign there? The T is like a plus, a cation. Yeah, you with me? So you can remember it that way. You can also remember, a student told me one time that cats, like meow, cats have paws. So cations are positive. Either way you want to remember it, that's fine. On the other side of the coin, we have chlorine. Chlorine had to gain an electron to fill its valence shell. So chlorine used to have 17, so it has 17 protons, but now it has an extra, it has 18 electrons, or it has 17 plus 17 minus 18, that's going to give me a -1 charge. So chlorine has formed an anion. Anions, also a compound word, not an anion, but an anion. All right, so these are the two things that elements on the periodic table want to form. So what we're going to see very often in something called ionic bonds is we are going to see that sodium is actually going to transfer or give this electron to chlorine, and this becomes like a win-win. And then sodium becomes positive and chlorine becomes negative, and sodium is happy and chlorine is happy, and then they stick together and we call that an ionic bond, and it's great. And that happens some of the time. And we call this process ionization, where sodium forms a cation and chlorine forms an anion, and then they form an ionic bond. But sometimes this can't happen. Sometimes the two elements both want to gain an electron, and they're both fighting over a free electron, or they're both fighting over an electron they think they could steal. And that's going to lead us instead to a kind of bond called a covalent bond, which is going to be a situation where two elements both try to grab the same electron and they end up locked in a battle to the death. And when they do that, we try to measure who we think is going to win in the battle. And we call that winner, that prediction of the winner, we call that the electronegativity. It's the ability to try to attract an electron away from another atom that wants that electron. And so the two elements need to be in a bond, okay, in order to do electronegativity. But this is a way that they try to grab those electrons away from another atom that wants it. So this fundamental process of ionization, or trying to ionize, or trying to fill your valence shell, trying to get your stable octet, is the foundation of a lot of the trends that you are going to be studying in the periodic table in our periodic trends project. Over the weekend and next week, you are going to spend some time getting to know each of these periodic trends. You're going to look at ionic radius. How big is an atom? Ionization energy. How much energy does it take to pull an electron off of an atom? Ionic radius. Once it's formed an ion, how big is it? Did it get bigger or smaller than its original atomic radius? And electronegativity. When these elements are in a bond instead of forming ions, how hard are they pulling on the electrons? How strong are they? What chances do they have of being able to pluck an electron away from another atom that doesn't want to get rid of it? These are all measurements that we can see trend on the periodic table. So we can see a regular pattern that allows us to predict if chlorine will be able to steal an electron from beryllium without knowing anything about chlorine or beryllium, just based on their locations on the periodic table. We will start to know things about them. It's like profiling, right? You start to get into their mind. You start to think like they're going to think, and you start to know what they're going to do without even needing to meet them. It's kind of cool little magic trick. All right, so that's what you guys are going to be working on your project. And you're starting out by just doing the first couple pages of the project where you really establish knowledge of what the periodic trends are. All right, you guys, we will talk more on your project when I see you in class.